Welcome back, everybody. I want to spend the next couple of minutes just briefly talking about the Tacho converter. It's ultimately going to be used where you had a 4-cylinder TAC and you've now swapped in a new 4-cylinder KR or a 180. There's loads of Mark 1s and Mark 2s out there with it. This little device will get your Tacho back up and working. This is what it looks like. Really small PCB, really compact. You could wrap that in a harness and you would never need to see it ever again. This is a 50p piece, and just for scale, it actually overlaps, or the 50p overlaps, the actual Tacho board itself. So why would you use one? Let's say we fitted a KR or a 180 or another 4-cylinder engine with an ECU that doesn't use a traditional ignition coil. The way the Mark II and the Mark I clusters worked is it used the high voltage collapsing of the coil, the ignition coil, so that the Tacho would show whatever RPM it was at. Modern ECUs don't use that. In the case of the 180, etc., they use or they have a 12 volt square wave output. So if we're to just do a little bit of Googling, if you are to look at pin 81 on the large T121 connector, you'll find a green and red wire, and that is what you would connect into the ECU cable. So if I'm to show you an overview of the board, this will go to your ECU pin, so your traditional 12 volt square wave pulse from your ECU that represents RPM. This one goes back to the cluster, so this is what is acting as the ignition coil. You've got chassis ground and you've got 12 volts from the battery. And that is it. 4 simple little connections. And if I'm to pull this up so that we can see it, I'm going to use CAN to cluster. Got it on my mobile phone here, and you can see here that I'm basically recreating the ECU signal that you would then get from ME7, etc. And you can see that needle sweep works, and if I'm to just go to a fixed RPM, I can choose an RPM on CAN to cluster, and it will sit quite happily at those RPMs. So that's really it in a nutshell. There's not a lot to it. It's very, very small and compact. You could wrap that in a harness for it never to be seen ever again. 4 reasonably simple wires that you can get to pretty quickly, and that would get your TAC working. For people that care, it is not a particularly complicated circuit. Ultimately, or originally, what people were doing is they were using the coil off of a relay. It was small, it was compact, but relays click when you start charging them and discharging them. So you can fill them with glue, you can take them to bits, you can do X, Y, Z. There's plenty to do with them. What I'm using in this circuit is a DR125 inductor. It's got a very similar resistance value to what you would use or what you would find in a relay. So very small, compact, shielded inductor to try and keep the signal, the noise to a minimum. This is a high voltage transistor. If you just use a normal transistor, you'll blow it in half. A couple of resistors as a pull up, and a base resistor to stop you jamming too much current into the base. And that is really all there is to it. This is the ECU signal. It comes in, it will turn the transistor on and off, and that will allow current to sink through and collapse the coil of this inductor. And that is all there is to it. Really simple little board, not much to it, and you can see there in the background we can just choose an RPM.